Hi, welcome to the OCI Classic to OCI Infrastructure as a Service migration lesson. In this lesson, we are going to look at the migration tools that you can use to migrate your infrastructure workloads from OCI Classic to OCI. My name is Sanjay Narvekar, and I'm a product manager from the Oracle Cloud Infrastructure product management team. Let us now look at the objectives for today's lesson. After completing this lesson, you will be able to discover resources in your OCI Classic Compute, Object Storage Classic, and Load Balancing Classic account using the Network and Resource Discovery tool. You'll also learn how you can migrate block storage volumes and virtual machines from OCI Classic to OCI. Let us now look at the two technical migration tools that you can use. The first one is the OCI Classic to OCI Discovery and Translation tool. This tool will help you discover the resources that you're running in OCI Classic, as well as do analysis and reporting. With the data provided by the tool, you can map your Compute Classic network configuration and security rules to OCI VCN. Using this tool, you can export the Compute Classic instance and storage volume details for migration. And finally, you can generate Terraform scripts for VCN creation and launching migrated instances. The second tool that we're going to look at is the OCI Classic to OCI VM and block storage migration tool. This tool allows you to migrate your workloads of VMs and attached storage volumes from Compute Classic to OCI, as well as inject migration scripts into source instances. Let us now look deeper into the Discovery and Translation tool. The Network and Resource Discovery tool allows you to generate reports of your object storage account as well as the networking objects, virtual machine instances, and load balancers in your Oracle Cloud Infrastructure Compute Classic and Load Balancing Classic account. You can use the output generated by this tool to analyze the networking objects that you'll need to set up in your Oracle Cloud Infrastructure tenancy and to identify the virtual machine instances and block storage volumes that you want to migrate. You can select an output format that works best for your requirements, and you can also filter the output using various commands and options provided by this tool. You can generate reports in the following formats: JSON, graph, spreadsheet, and Terraform. Let us now look at the process overview for discovery and translation. You start off by installing the Network and Resource Discovery tool, and this tool can be installed on Windows, Mac OS, and Linux. This tool is bundled in the block and VM migration image that customers can use for migrating the block and VM instances from OCI Classic to OCI. Once the Network and Resource Discovery tool is installed, you will then configure the tool with your OCI Classic credentials information. And then you can execute the tool to discover network and compute resources in OCI Classic compute environment. Once the discovery is complete, the tool will create a JSON file which has the information of your OCI Classic environment, and that file can be used to generate a list of instances to use with the VM and block storage migration tool. You can also use the information in that JSON file to create Terraform configuration file for creating network resources on OCI. Let's now look at the considerations for using the Network and Resource Discovery tool. Before you run the Network and Resource Discovery tool, consider the following suggestions. The tool doesn't modify any resources in the source environment. However, it is recommended that you run this tool as a user with a minimum required read-only access. The recommended user privileges are compute.compute_monitor for compute classic, lbas_read-only group for load balancer classic, and storage_read-only group for storage classic. This tool generates a Terraform configuration file that can be used to create your network resources in a single availability domain on Oracle Cloud Infrastructure. Using this tool to create resources across multiple availability domains in the target environment isn't supported. Let us now see how you can set up your profile for the Network and Resource Discovery tool. The Network and Resource Discovery tool connects to your source environment using connection information that you provide in a profile file. The information you provide in the profile file includes the username or identity for each service in the source environment, as well as the service endpoint and region. You'll need the username and API endpoint for each service. Look up service-specific details in your Oracle Cloud dashboard. You can use the following template to create your profile file. Replace the sample values with values specific to each service. And this is the template file that you can use. You'll capture the information for the compute user and compute endpoint from the compute classic dashboard. Similarly, you'll capture the username endpoint and region from the LBAS dashboard, and then you can also capture the pass and object storage credentials and information from the respective services. Note that passwords aren't specified in the profile file for security reasons, and you'll be prompted to provide the password for each service when you run the tool. If required, you can create multiple profiles in the /home/opc/.opc/profiles directory. Use the -- profile option to specify the profile file you want to use when you run the tool. If no profile is specified, the default profile is used. Note, you'll have to create the folder structure underneath /home/opc.opc profiles if you don't already have it. Let us now look at a demo for the Network and Resource Discovery tool. I will now show you a demo for the Network and Resource Discovery tool. I have logged in into my OCI Classic dashboard. I will click on Create Instance, click on All Services, and click on Create for creating a Compute Classic instance. Once I'm in the Quick Start dashboard, I'll click on Show All Images, and I will scroll down further and click on page number 2, and then select the OL 7.5 migration image and click Next. I will select the OC7 general purpose shape, select Next, and if needed you can change the name of the instance. Make sure that you select an SSH key, and if you do not have an existing SSH key you can add an SSH key by pasting the value or selecting it from a file, and then make sure that you give a name to the SSH public key. I'll hit cancel here because I already have a bare metal SSH key there. I'll click on Next, and this is where I select the shared network for this migration instance. I will select the default security list and then click on Next. And the 12 gigabytes of storage space for the boot volume is not sufficient. I'm going to update it and set it to 2000 gigabytes. Click on Update, and then click on next. And here I'll review all the options and values that I provided for the instance creation, and I will click on create. So once I click on this create button, it's going to take a few minutes for the cloud process to create the migration instance. In the interest of time, I already created this instance. My migration instance has now come up and have logged in into the instance using an SSH tool. So to get started, let me just show you the contents of this folder in my /home/OPC folder. The image comes with the bin, the OCI Python SDK, SRC, and Ansible folders along with the Meg executable. Before you get started with the network and resource discovery tool, you need to make sure that you create the .opc profiles folder. And in this folder, you're going to create a file which will have the values of your endpoints. Now, let me just show you what I have captured in my default file. This has my username for compute along with the endpoint, username for the LBAS user with an endpoint, and also the username, identity ID, endpoint, region, etc. for PaaS services, and the authentication endpoint, username, and the endpoint for the object storage. And you'll have to capture this from the OCI classic dashboard. Let me just show you how to go about capturing the value for the compute classic instance. So I'm in the dashboard here. I'll click under this compute classic and select the action menu and click on view details. So when I'm here, that's where I get this REST endpoint from. So similarly, you will do the same for the storage classic, load balancer classic, etc. and capture the information that is needed for the different services. So once you are done with capturing this information, you are now ready to execute OPC Migrate Discover. The first time you run this tool, it's going to ask you for the passwords for all these services. In the interest of time, I have already populated those passwords into a password file in my home.opc profiles folder. So it's not asking me for the password, but first time you run it, it'll ask you for the password. Just make sure that you're aware of it. Once the OPC Migrate Discover process concludes, it's going to store the values in a file called resources-default.json. And the reason it is storing it in this file format is because I didn't specify a profile to use and it went with the default. Now if I had specified a profile of Sanjay, for example, it would have created resources-sanjay.json. Yeah, like I said, so watch out for those files as you run those OPC Migrate Discover commands. Let me quickly show you how you can look at the contents in this file. You can use the view command, and over here you can look at the values for all your resources. Now I won't go into all this, but Um, Once you have this resources file, you can get started with the other commands that will help you with the planning activities. You'll have to first create a plan using the JSON file that was created in the previous step. So I have pasted the command in the interest of saving time here. So the format is OPC Migrate plan. Then you specify create file resources default.json, which is the input file, and the output will be a file which you can name whatever way you like. But I have selected the name of migration-plan.json. So this will create the migration plan.json, and using this plan you can uh, create additional things like generating a list of instances that you can use with Terraform. So one such example is OPC Migrate instances export, and use the plan that was created in the previous step, and then specify the output format to JSON, and specify the file name. And let's quickly look at instances.json. So it creates a file in the JSON format, and it has all the list of instances that are discovered in your OCI Classic account, along with the type of operating system. In my case, I have like few Linux instances and I have a Windows instance. In the case of Windows instances, it has specified a value for OSQ, and these values are not specified for Linux instances. Note that. Also note that if you're running this job for migrating these instances, you will have to specify values for OS kernel version for Linux instances, as well as the shutdown policy for your Linux instances. And the values for shutdown policy are ignore, shutdown, and wait. So let me just quickly add these values to the first instance. So this is how it's going to look like once you add it, and make sure that you add these values for the other instances that are Linux as well. And you can use this JSON file as an argument when you're running the migration jobs for moving your block storage and VMs from OCI Classic to OCI. So enough of that. Let's look at a couple more things before we wrap up with this demo. So another additional thing that I want to show you is the OPC Migrate Spreadsheet creation command, which is the OPC Migrate report. So this command will take the input from the resources-default.json file, and it will generate a report in a spreadsheet format. And just to show you, that's the file that it has generated. Now I have already copied this file over into my desktop. Let me quickly show you how that spreadsheet looks like. So if you see this spreadsheet here, it has multiple tabs. It has information on all the instances that's running in your OCI Classic account, the platform, whether it's Linux or Windows, the SSH keys information, the IP address associations, reservations, like if you have any IP addresses reserved and associated with this instance, the IP networks, etc. So You can use this information in your planning exercises, and also note that since this spreadsheet has sensitive information, you may not want to share it with folks who don't need to have access to this information. So that was generating the spreadsheet. Then the other command that you can look at is to create a graph, and you run OPC Migrate graph, which will generate a PDF file for you, and that's the PDF file that was generated. Now I have also downloaded this file into my desktop. Let me quickly bring that up so that you can look at it. So this is the graph file that was created for all the resources in my classic account, and you can use this in your planning exercises. Now there are additional things that you can do while um, generating the migration plans. You can use the focus, the include and exclude parameters for specifying the networks or the instances that you want to migrate or create this graph for. So keep that in mind. You can find information all this in the documentation. I won't dive into that right now. If you want to generate a Terraform file for creating your networks or creating the shell for the instance creations along with the network information, you will run OPC Migrate along with the generate argument and specify whether you want to generate the networks with all the security rules, and you have to pass as an argument the migration plan JSON which was created in the previous steps, and for the output you can specify a file name of main.tf. So once this command executes, it will generate the main.tf, and there are some warnings that you can pay attention to, and usually this comes about if you have instances mapped to multiple networks or multiple Linux sets, etc. And if it's something that you can ignore, go ahead and ignore it. If not, pay attention and address it before you go about creating the instances using the Terraform file. So let me just look at this main.tf so that you can get an idea of what it has. So it's a basic Terraform file with arguments and values for the OCI classic provider, and as you can see that it has information for creating networks, the security lists, the rules for the security list, etc. So that was creating the Terraform file, and that concludes the demo for the network and resource discovery tool. So over here we saw how you can discover the resources in your classic tenancy, and then generated a spreadsheet using the OPC Migrate report command, and we generated a graph using the OPC Migrate graph command, and then we also saw how we can create a Terraform file for creating the network and resources, as well as command to generate the instances which can be used as an argument for the block storage and VM migration tool. So that concludes this demo. Thanks for watching. You just saw a demo for the network and resource discovery tool. Let's now move on to the virtual machines and block storage migration section. In this slide, you'll see an architecture which shows resources in your OCI Compute Classic account being migrated to your OCI tenancy using the VM and block storage migration tool. The VM and block storage migration tool provides an image for you to create a migration controller instance in the source environment. This migration controller VM contains tools and scripts that you can use to configure your source VMs for migration. The migration controller VM in the source environment also sets up another migration controller VM in the target environment. These migration controllers are together used to collect information about the source environment, copy data, create images from boot volumes, and create the required images and data volumes in the target environment. Let us now look at a high-level overview of the migration process for migrating virtual machines and block storage from OCI Classic to OCI. You start off by launching a migration controller instance in OCI Classic. You will then configure the instance with information required to access the target OCI environment. You'll have to create an OCI storage bucket and a pre-authenticated request URL for access, and that information along with OCI Classic and OCI target environment information needs to be configured in the Control S instance. Once this is done, you will execute OPC Migrate instance service setup and OPC Migrate instance source setup to configure the Control S environment and also to ensure that the source instances in OCI Classic have the necessary drivers and have the right kernel configuration that will allow these instances to come up without any issues after migration to OCI. You'll also need to create or select an OCI compartment and a VCN subnet for the creation of the control T deployment. Once you execute OPC Migrate instance CATLT setup, the target control environment gets created in OCI. You are now ready to start the migration process. You can use the instances.json file generated in the resource discovery step as an argument to the OPC migrate command. Once the migration process starts, the VMs and block storage volumes are migrated from OCIC to OCI. Let's now look at certain considerations for migration. Before you start your migration, consider the following factors that could have an impact on your migration process: proof of concept, boot volume size, etc. This solution requires the following services and roles. In OCI Compute Classic, you'll need the compute operations role to create the migration controller instance and to create snapshots of the boot and block volumes. On the OCI side, you need to ensure that you have policies in place that allow you to read the required OCI IDs from the web console. You'll also need to create an API user who must belong to a group that has policies in place to create the required resources. Let's now look at the planning process for the migration. Before you start the migration, you should collect information about the source instances that you want to migrate, generate and have available the required SSH and PEM keys to access the source and target environments, configure the source environment with the required drivers, and ensure that the file systems that are attached to the source environment are properly configured so that they get attached in the OCI side. You'll set up the network in the target OCI environment and collect information from the target environment necessary for the setup of the Control S server, and ensure that before you begin your migration, you complete the prerequisites. Let us now look at the process of launching the migration controller instance in the source environment. In your OCI Compute Classic account, create the source controller, also known as Control S, with the following configuration. You can use the web console or any other interface to create an instance with the following specifications. You'll need to select the OL underscore 7.5 underscore UEK R4 underscore x86 underscore 64 underscore migration image, which is available under Oracle Images on the console. We recommend that you select the general purpose OC7 shape or any other shape with a sufficient number of OCPUs for the migration. Associate an SSH public key with the Control S instance, and you'll use the corresponding private key to connect to the Control S instance. This key isn't the same as the SSH key pair used to access Linux source instances from Control S. While creating the instance, make sure that you select the shared network with a persistent public IP address and use the attached default security rules that allows SSH inbound access. Also ensure that security rules are in place to allow SSH outbound, SMB inbound, and HTTPS outbound traffic. The Control S instance must be able to connect via SSH to the source VMs and must be in the same identity domain and site. In terms of storage requirements, use one of the following criteria. You can have a boot volume of 2 terabytes if the total size of all boot and attached volumes to be migrated is 1.2 terabytes or less. A boot volume of 128 gigabytes and additional storage 1.5 times the size of all boot and attached volumes to be migrated, mounted on slash images. Note, limit on OCI Classic limits are 2 terabyte per block volume. To extend, use LVM with multiple 2 terabyte block volumes. Ensure that you format and mount this additional storage under slash images. Once the Control S instance has started in OCI Classic, connect to the instance using SSH. All of the tools required for the migration are already on the machine, but you need to configure additional information for ensuring that the tool is configured correctly to access the source and target environments. You can download the latest code and configuration files by executing /mig install on the server. All of the configuration settings are in a file called secret.yml, and this is located under /home/opc/ansible folder. You can use the sample file available in the same folder to create your secret.yml file. Enter the details of your OCI Compute Classic account and your OCI OCIDs, and also provide a list of instances to be migrated. So in this screenshot, you will see that this YAML file has the information for the compartment ID, the user ID, the fingerprint for the API key, the tenancy ID, the region, and the availability domain for the infrastructure. And for the Control T instance, it is going to be using Oracle Linux version 7.6 and a VM shape of vm.standard 2.1. The same file is shown in this slide as well, and this is basically a continuation. We have to also specify the subnet ID, and this is where the Control T environment is going to be attached to. And if your OCI PEM file has a passphrase, you specify the passphrase here, and you also specify the par URL for the OCI underscore OCI sig bucket that you created in the OCI object storage compartment. And you now see that you have to also specify the OCIC information, which is the username and the password, and the profile endpoint. Here are the setting informations that you need to specify for control S instance. And then finally, this is where you specify the list of instances to be migrated. And note that if you do not specify this list here, you can also specify this as an argument to the job by specifying the file in a JSON format. Let us now look at additional details on specifying information about the VMs in your source environment that are going to be migrated to OCI. In addition to the instance name, you also have to specify the operating system for the instance. It can be Linux or Windows. In the case of Linux instances, you leave the OS SKU parameter field blank, but you need to specify the OS kernel version parameter, and this value is required for deciding whether an image will be imported in emulated mode or para-virtualized mode in OCI. You also specify the following required attributes for Windows instances. The first one is the full name of the instance, and you have to set the OS parameter to Windows. In the case of specified launch mode field, when it's used with the Linux instances, the virtualization mode specified there is used, and the virtualization mode derived from OS kernel version is ignored. For Windows VMs running in OCI Classic, you need to specify a value for the OS SKU field. Valid values for the OS SKU field are Server 2008 R2 Enterprise, R2 Standard, R2 Data Center, or Server 2012 Standard, Data Center, R2 Standard, R2 Data Center, or Server 2016 Standard and Data Center. You have to specify the OS kernel version for an instance only if required, and this is useful if you have VMs created from custom images or bootable volumes restored from snapshots, or VMs created using OCI Compute Classic images where the guest OS has been updated after launching the instance. To specify that you want to skip migrating the boot volume of an instance, set the attached underscore only field to true. To migrate the attached storage volumes, specify the volume names for specified underscore volumes underscore only field. If this list is empty, all volumes are migrated. Use the field shutdown underscore policy to specify if the instances to be migrated should be shut down during migrations, and if so, how. Valid values for this field are ignore, shutdown, and wait. And wait happens to be the default behavior. Use the field specified underscore launch underscore mode to specify the launch mode for the migrated image. The valued values are para-virtualized and emulated. You can also use the volumes parameter to specify the unattached storage volumes that you want to migrate. You can use this list to specify storage volumes restored from co-located snapshots as well. To apply the configuration to the control S server, you will execute OPC Migrate instance service setup. You will then copy the PEM key required for the OCI API connection to the file /home/opc/OCI/OCI_API_key.pem on the control S server. Make sure that you modify the permissions on the key file to restrict access to other users. Once the control S server configuration is complete, You are now ready to prepare your Linux source instances for migration. You need to configure your source instances so that they can be reinitialized correctly in the target environment. You can configure your instances either by using tools provided by the Control S instance or manually using custom tooling or fleet managers. To prepare the source instances using a script on the Control S instance, ensure that you have SSH access from Control S to each Linux source instance. Copy the private SSH key for each source instance to the Control S instance, and remember to modify permissions on the key file to restrict access to other users. Verify that all volume mounts are set to _netdev and no fail in the /etc/ftab file so that when you launch VMs in Oracle Cloud Infrastructure for the first time, when volumes aren't mounted, the instance can start successfully. Make a note of the IP address, sudo user, and the path to the SSH private key for each Linux source instance. If you use the network and resource discovery tool to identify resources in your source environment, you can find this information in the instances.json file generated by that tool. On Control S server, create or update the /home/opc/ansible/host.yaml file. You can use the provided host.yaml.sample to create your host.yaml file. This slide shows a screenshot of a host.yaml file. Note that you will need to have entries for all your source hosts that you're planning on migrating from OCI Classic to OCI specified in this file. Once this file is configured properly with the IP addresses, the remote users, and the private key files for all your source instances, you can run the following command to configure your Linux source instances on the Control S server. The command is OPC Migrate instance source setup. Once this command is executed, review the output from this command. In addition to other tasks, the script checks the Linux kernel to determine whether it's eligible for para-virtualization after migration and whether the necessary kernel modules are available. The output recommends the missing kernel modules to be added. Ensure that you back up the boot image file before running any dracut commands modifying the image. Let's now look at preparing your Windows source instances for migration. Use the script provided in the Control S server to set up your Windows instances for migration. For each Windows instance that you want to migrate, do the following. Ensure that you have RDP access to each instance as the administrator. Use RDP to log into the instance as the administrator. Copy the file /home/opc/src/windows_migrate.ps1 from the Control S server to each source instance. On each source instance, navigate to the folder where you have saved the file and run windows_migrate.ps1. Once the source environments are set up for migration, you are now ready to launch the migration controller instance in the target environment. Use the setup script provided in Control S to launch the migration controller in the target environment. Log into the Control S server and run the following command: OPC Migrate instance ctlt setup. Once that command is executed, the control T or the control target instance comes up on the OCI environment. Once this instance is ready, you are in a good shape to start the migration for moving your VMs and block volumes from OCI Classic to OCI. Migration is kicked off by executing OPC Migrate instance job run. The migration tool then starts the migration process for the boot and attached block volumes specified in the secret.yaml configuration file. If you want to run multiple jobs in parallel, specify a job file for each job. The command to execute the jobs is given below. It is OPC Migrate, Migrate instance, job, run, and you pass an argument for job file, which is the full path of the job file name. To monitor the status of all migration jobs, execute OPC Migrate, Migrate instance, job list. And to monitor the status of a specified migration job, execute OPC Migrate, Migrate instance, job status, and you specify the job name. To monitor the status of the migration service, run OPC Migrate, Migrate instance service status. If you want to interrupt or resume a migration job, log into the Control S server and run OPC Migrate, Migrate instance service stop to stop the job. If a migration job fails, then to resume only the specified migration job, log into the Control S server and run OPC Migrate, Migrate instance, job resume, and specify the job name. To restart the migration service after it has been stopped, log into the Control S server and run OPC Migrate, Migrate instance, service start. Here's a diagram which shows how the boot volume migration happens when the migration job executes. First, the boot volume is snapshotted and a clone of the snapshot is created, which is then converted into a QCOW2 image, which then gets uploaded to the object store in OCI. And then finally, a custom image is created from the QCOW2 image, which can be used to spin up target instances in OCI. In the case of storage volumes or data volumes that are attached to the source instances in OCI Classic, the data volumes are first snapshotted and then a clone of that volume is attached to the Control S instance, and the Control S instance executes the dd command over SSH to do a bit by bit copy of the data to a volume which is attached to the Control T server. Once the entire copying is done, the target volume is detached from the Control T instance and the source clone volume is detached from the Control S instance, and the clone as well as the snapshot are deleted from the OCI Classic account. The migration tool doesn't launch VMs in the target environment. You must create the required VMs yourself using any of the documented methods to access Oracle Cloud Infrastructure. Use the custom images created by the migration tool to launch your VMs, and ensure that you create the VMs in the same availability domain that you migrated them to. If you change the availability domain while launching the VM, you won't be able to attach block volumes to the VM. After you launch VMs using the OCI console, attach the required storage volumes to each VM. To mount the attached storage volumes on each migrated instance, log into the Control S server and run OPC Migrate, Migrate instance attachment ready, and specify the instance OCID. Confirm that this process has completed successfully. View the log file, that is /OCIC_OCI_meg /inject_script/logfile.log. You should see the following message at the end of the file. Clean up the cron job for inject_script.sh. This message indicates that the volumes have been successfully mounted. You can alternatively run the scripts on the boot volume of the migrated instance to mount the block volumes. Log into each migrated instance and run the following commands: cd/ocic underscore OCI underscore make, sudo dot slash iscsi attach.sh, sudo python dot slash process underscore manifest.py. After the scripts complete, reboot the instance. When the instance restarts, use the lsblk command or view the /etc/fstab file to verify that the attached block volumes are mounted. If you are using a custom configuration that depends on the disk device names, you may need to perform some manual configuration. For example, the migrated instance's LVM filter will be automatically modified to accept all devices named /dev/sd star. If you are using a custom LVM filter configuration, you may need to manually edit the filter and or global underscore filter entries in /etc/lvm/lvm.conf to accept only the appropriate devices. Once the migration process has completed and the instances have come up along with the block volumes attached, you need to validate your VMs and block storage in the target environment. Validate your Windows licenses in the target environment by logging into the Windows VM using RDP and then executing the command slmgr /dli in PowerShell or a command prompt window. The Windows script host dialog box appears. Verify that the new KMS address 169.254.169.253 is displayed and that the license status is licensed. You should then validate the network setup, confirm that the instances are running, and verify that network access to each instance is both permitted and restricted as intended. Let's now look at the migration tool demo. I will now do a demo of the block storage and VM migration tool. So I'm back in my OCI Classic dashboard. I will show you the instances that I'm currently running in my OCI Classic account. You can see that I have a few of them running. The migration instance is what I have named Panda New, and I have a few other instances here. I have a Windows and a few Linux instances. I will not be migrating all those instances, but for today's demo, I will just show you the migration of one of those instances. Alright, so I'm now logged in into my migration instance, and this is the same instance I used to do the demo of the network and resource discovery tool. I will go into the Ansible folder and quickly show you the secret.yaml.sample file. So this is the file that you need to use as a template for putting in the values for your OCI and your OCI Classic account information. So you'll have to capture information from your OCI tenancy. The values you'll need are compartment OCID, user OCID, the API key fingerprint, the tenancy OCID, the region name, availability domain, as well as the shape and Linux version for your control T environment that's going to be running in the OCI account for the migration process. And you'll also need to specify the subnet ID for the VCN that's going to be used to run the control T environment. And if your OCI PEM key file is associated with the passphrase, that passphrase needs to be specified here. And as a prerequisite step, I think I had mentioned that you'll have to create a par URL for your object storage bucket in OCI. The par URL needs to be populated here, and this is where you specify the OPC endpoint, the password, and the container, and then you specify the information for the target control instance and storage. And optionally, if you want, you can specify the instance names along with the OS type, the OS SKU in the case of Windows instances, and you'll also have to specify the OS kernel version in the case of Linux instances, and the shutdown policy also. Note that if you specify attached only false, you will be migrating all the attached block volumes to the instance. If you specify attached only is true, then the boot volume will be ignored during the migration. You can optionally also specify which volumes you want to migrate by specifying them in the specified volumes only parameter. So that was secret.yaml.sample. I have created a secret.yaml from that file, but I won't be showing it to you because it has sensitive information. And I have also used the JSON file that I created, and I have created multiple instances JSON files for specifying the jobs. In today's demo, I will just use the j1.json file, and in this demo I'll be migrating this Jenkins instance, and I've specified the kernel version of 4.1.12 and a shutdown policy of shutdown. So when this job gets kicked off, it is going to shut down this Jenkins instance which is currently running, and it's going to do the migration, and then it will conclude the migration. So that was configuration step, and the first thing that you need to do after you run the parameters into the secret.yaml file is to apply the configuration to the control S server. So in order to do that, you will execute OPC Migrate instance service setup. So this process takes a few minutes, and once that is done, the instance will be configured for use in this migration. Let me make the screen larger so that you can see this more clearly. And the next step you will do is to start the migration service, and in order to do that, you execute OPC Migrate instance service start, and this will start the migration service. And we have now done two things, right? We have started the migration service, and prior to that we have edited the secret.yaml file and configured the source service. So what we are going to do next is go back to the Ansible folder and edit the host.yaml file, and you can use the host.yaml sample file and create the host.yaml file from that. Let me just do a cat of the host.yaml.sample. So this is what it looks like. So what I've done here is I've used that as a template and created my host.yaml file, and my file looks like this. It has the public IP address of my servers along with the labels, the remote users, and the SSH keys that is needed to access them. So let me quickly show you the first one as an example. The Bitnami WordPress server that I have has a public IP of 129.150.176.11. So I've properly configured it with the IP address. And for the label, I have to do one simple thing. I click on Bitnami WordPress, and what I see here, following the Bitnami WordPress string, that's the one I need to capture and paste here. So I just wanted to show you this as an example so that you know where you can get this information from. And once I get this information, I go back to the home directory, and I'm now ready to do the setup command of the source instances. So I run OPC migrate instance source setup. So when this command runs, the tool will look at all the hosts in the host.yaml file in the Ansible folder, and it will log in into each one of the servers and make sure that it is configured properly for the migration. Now you'll see the results in a few minutes, which will show you the checks and any warnings, if any. So as you can see, it didn't find any major issues with this check, so we might be ready to get going with the migration process. So what I now need to do is to start the control T server in my OCI environment. So to do that, I'll run OPC migrate instance ctlt setup. So when this process executes, it will launch an OCI compute instance in my tenancy, and it's going to use the information I specified in the secret.yaml file. I'll have to select the compartment that I'm using for this demo, and as you can see, it is starting a new control T environment. So this is going to take a couple of minutes, and I will not get the command prompt on this shell prompt till I get a green here. My instance is in running status, as well as a block volume has been attached to this server, and that block volume is going to be used in the migration process. So let's wait for a few seconds and then get going with the demo. The control T instance is now running, and the attached block volume is also showing up in my OCI console. We should be getting a command prompt here pretty soon, and there it is. So we now have the control T environment configured in OCI, and we can get started with executing our first migration job. As I mentioned earlier, I will just be running one instance migration in today's demo, so I will use the j1.json as an argument to the instance job run command. The job was submitted, and the migration job is in pending state. Now let's quickly look at the OPC console and see what's happening there. We can see that the Jenkins instance is right now in a state of stopping. This will take maybe a couple of minutes, and once it changes to a stopped state, then the migration process is going to start running over here. Now, if I want, I can monitor this job status by typing OPC migrate instance job status, and then I copy the job ID from here and paste it. And this is the job status, and as you can see here, it's in a pending state, and it's pending because we are waiting on this instance to shut down completely. I'll pause for a couple of minutes, and once it stops, then I can show you what's happening with the migration. Okay, then my Jenkins instance is now in a stop status. I'll quickly look at the job status, and you can see it's now in the process of cloning the snapshot for the storage volume, and it's going to get started with the migration soon. So let's do this, right? Let's go to the images folder and go to the migration log. Let us now look at what's happening in the run_migration log. Over here you can see the detailed logs of the migration process. So while this is going on, let's go into the OCI console and see what's happening over here. There are no new custom images for today. Let's look at the object storage. We are now looking at the contents of the OCIC-OCI-Meg object storage bucket, and you can see that there are a bunch of files from previous migration jobs. And one key thing to notice, the instance names and the storage volume names will also have the job IDs associated with that particular migration process. So if I can look at this one here, this is the file that was created today from the migration process in the QCOW2 format. Once this file is stored in object storage, the migration process will create a custom image of that file, and there you go. It has started the process of creating a custom image for this QCOW2 format that was copied into object storage. And once this custom image creation completes, you can use this for launching new instances. And I will not wait till this completes, but this is the same boot volume that was created into QCOW2 format and then created into a custom image in OCI. And as you can see, like, you can use this custom image to create new instances, and once you create a new instance, you will be able to use it in OCI. And key things to note is you'll have to create your virtual cloud network before you create this custom instance from your image. So that is the demo of the migration process at a high level. Thank you for watching. Have a great day. We just saw a demo for migrating block storage and VMs from OCI Classic to OCI, and that concludes the lesson. In summary, you learned how to discover resources in your OCI Classic compute using the network and resource discovery tool, and you saw how the block storage volumes and virtual machines can be migrated from OCI Classic to OCI. Thank you for watching today's lesson. Have a great day.